So, bonjour friends, this is PNSS Pranav, and today we are gonna make our day beautiful. So, to make our day beautiful or this time, actually introducing by myself, I am an OT, I am an out of box thinker. So, this today we are gonna do a crazy experiment. We are gonna open this battery as you know white batteries they use in other devices, but do you know how they store energy in themselves? Means they store such an energy in themselves for a long time. Okay, so today we are gonna open it live and we are gonna see what it consists of and how it stores and the mechanism. It's not any boring physics or chemistry class, it's an interesting thing and a thing which you'd love to see. Okay, I love to present you, so let's get started. And frankly speaking, um, it, it had been a long time from opening this battery actually. So yes, as it is a double A battery is also called as double A or micron battery. Means it has standard size single cell or it's a dry battery actually. So its size of R6 and its value it has system of 60086 system and it anesthetic and it calls of size 15 double A batteries and commonly they are portable electronic devices. They are these can be heavy, these are used for heavy duties. As triple A batteries they store less. This is a dry cylindrical cell. That's it. Okay. Yes. Now opening it, it's a tough time, but okay, I'll try for you. And so, for this thing, you need a knife, a very sharp edge knife, and the battery, and a plain sheet, and this must be done under parental guidance. Okay, so as I have been carving this battery, just rimming out its peel. Okay, right. Yes, okay. The tough thing to be done. Okay, or else. Yes, done. I have done a bit of peeling and this came to the shape. I have removed its anode point as you can see and this battery I have halved it. So inside this I found some black powder means and this. I was been very curious and I have searched a very common questions on this black powder in the Google and other net browsing. So I didn't get the accurate information. So hence I got it finally. Then it was actually a thing which is very interesting. It is it is known as carbon black, the carbon black or acetylene black. It is used in the anode to deliver high conductivity in the cathode. Means in this is cathode and anode. Cathode means the positive end and anode means the negative end. As this is another battery. You can see this. This is the positive end and negative end. And this is the cathode of it. So this thing actually in a circuit the electricity flows from the positive end to negative end. So to make it happen and more efficiently as it's not a circuit actually, it's a part of circuit actually. So to make it efficient we use the acid and carbon in it. Okay, and then after opening it up, yes, this black powder we have found it and some may use white powder also. Some may use white power too. So those are at the end of the battery cells, which is cathode and anodes. They does not make the battery leak. Okay, it does not make the battery leak. And you see, white powder, they have been caked up. And the most interesting thing which I have found inside the battery was this. Yes, this lead. This lead, actually, it's too inconvenient to show you, but this is a small lead pole. Means it is not the lead which you use in the pencil. It's made of plumbum, PB, lead. So it is a thing. It is a main part of the thing. I mean, battery. See, it stores the energy and it preserves the energy. Yes, it preserves the energy. It will not make the energy leak. It stores energy in it. You may be having a question. So lead, you say the pencil lead and also this lead is different. Do they have both anything in common? Yes, they have. They have a very similar thing, but other than the other elements in the battery, other than the other elements in the battery, and that is if pure lead is a conductor of electricity, is a conductor, but unpure lead means it is mixed up with some alloys, then it is a pure insulator, means it does not allow electricity to flow through it. So one man, two faces. So this is the same scenario as this thing. If when it's pure, without mixing of no alloy, and it's unique, then it is a pure conductor. Means it will open the gates to electricity to come in. Just cakewalk. But if small amount of some 0.40% of alloy is mixed, then that's it. It becomes an insulator. So that's why that is used in a battery as well as yes, in some fuse. Yes, best example, fuse. What is a fuse? Why is a fuse used? You may be thinking I'm taking some physics class. No, guys, I'm just making you aware. Just I'm discussing a few topics. Okay, as this is an EDU video, educational related video. So then, yes, use when you see a circuit. Circuit is a simple thing, which is a battery, a cell, and a cell and battery. Sorry, a battery and a bulb. So the current electricity flows from the battery to the bulb, and that's it. That's a simple circuit and a switch if you need. So if the load of electricity increases or decreases, then you may short circuits may occur. You see, you know short circuits, as the whole circuit board over there will get flamed off, burned out. So this fuse, it has lowest melting point, means it can melt to some high temperature. So when the flow of electricity is more, it melts and the wire breaks. So no current electricity will flow. So no damage, no short circuit. This is about the fuse, and that's it, guys. Today I wanted to share about opening of the battery, and it has really gone well. Yes, you can see through this hole inside. This thing is the pole fixed in between of it, and it is the positive end, and it is the negative end, and this is the battery. Yes, right. So do not try this at home. Actually, it's not so practical to explain because you cannot make particles float or something. It's just a theoretical experiment or basic experiment. So try not to cut. But in this experiment, I have cut an already used battery, means which is dead now. A dead cell I have used. So do not waste the new cells in the home. Okay. Hoping so you have learned something from this video. It's been my pleasure explaining you. Thank you.